Repercussions of El Nino and La Nina in Asia. El Nino is characterized by unusually warm ocean currents in the equatorial Pacific as opposed to La Nina, which is characterized by unusually cold ocean temperatures in the equatorial Pacific. Quote, El Nino is a disruption of the ocean atmosphere system in the tropical Pacific, having important consequences for weather and climate around the globe, unquote, according to the website of the National Oceanographic and Atmospheric Administration of NASA. Nowhere is the effect of ocean currents more dramatic than along the coast of Peru in South America. The coastal plain of Peru is a 1,920 kilometers desert that is almost entirely barren. Paradoxically, the seas along the desert teem with life, forming one of the richest fishing grounds in the world. The key to this paradox is the Humboldt Current. Moving north from frigid Antarctic waters, the Humboldt Current churns up enormous quantities of nutrients for sea life. But where the current hugs the coast, it traps the land between its chilly waters and the Andes Mountains, which forms a moisture barrier to the east. But during normal times, the Humboldt Current turns west of northern Peru, just south of the equator. The sea and land above the turn are truly equatorial in climate, warmed by a weak southerly current, the El Nino. In the southern hemisphere, anti-clockwise oscillations are normal. Once in a few years, this periodicity has not been documented precisely yet. This anti-clockwise oscillation reverses to clockwise oscillation, stemming from the Southern Ocean to the east coast of Australia, New Zealand, and traveling north till the equator before turning east towards the west coast of Peru. This then is the El Nino reverse oscillation. Remember, reverse in the southern hemisphere is clockwise oscillation. For reasons that scientists do not fully understand as yet, the Humboldt Current sometimes starts its turn further down the coast, permitting El Nino to flow farther south than usual. And suddenly the desert comes to life. Scientists are still documenting the periodicity of the reverse oscillation, but it appears to occur once in every 4 or 7 or 11 years. The effect of each El Nino reverse oscillation lasts for about 12 to 15 months. Thereafter, the La Nina, which can also appear at infrequent intervals, may appear immediately after the restoration of the ENSO or after a gap. When it does, El Nino ushers in a sea change of weather patterns. The winds that are powered by the ocean currents, pushed or heaved by the reverse oscillation, carry far into the various continental land masses. While El Nino is the humidifying effect, its corollary, the La Nina, epitomizes the cooling effect of the winds and westerlies affected by the reverse oscillation and ocean currents. El Nino, being the warm current, unburdens the moisture condensed from heat islands and warming atmosphere in its path and accounts for increase in ambient temperatures. Droughts and floods are more accentuated. Winters are either washed out or summers become intolerably hot. These accentuated changes are visible in the normally mild tropics, thus marking a major change in weather patterns in the tropics. Among these consequences is increased rainfall across the southern tier of the United States and in Peru, which has caused destructive flooding and drought in the western Pacific, sometimes associated with devastating bushfires in Australia. Observations of conditions in the tropical Pacific are considered essential for the prediction of short-term, that is a few months to a 1 year, climate variations. El Nino South oscillation is followed intermittently by La Nina, which cools the planet inversely proportionate to the degree of warmth ushered in by ENSO. La Nina empties the cool air and moisture gathered by the current in cooler climes. It's a case in point to prove how nature balances herself for our benefit. The cool current of La Nina is responsible for a severe cooling of the planet, with hyper cold winters even in places which are humid. Summers are also mild during La Nina period. The quantum of rainfall is unusually high in the La Nina years. When El Nino South oscillation unleashes droughts, La Nina brings in floods, wreaking sheer havoc on the agricultural production, soil fertility, ecosystem conservation, human society, economy, and civilization itself. For a deeper understanding of the repercussions of El Niño South Oscillation, you may wish to study this link of National Oceanographic and Atmospheric Administration (NOAA). We are still at a nascent stage of understanding El Niño South Oscillation. It is only after understanding El Niño South Oscillation, or ENSO, that we can get a clearer insight into climate change. Dear students, now that we have understood Asia's terrain patterns, rivers and their drainage patterns, natural vegetation and ecosystems, ethnic composition, demographic patterns, traditional vocations, weather patterns and climate, we should be able to get a clearer picture of agricultural patterns. So, in the next chapter, we will learn about agriculture, horticulture, floriculture and fisheries in Asia. Please do ensure you catch us again for the next lecture. Until then, take care.